Enjoy the lesson and pay attention. I'll be keeping an eye on you.
Hello everyone, and welcome to another exciting lesson on TIBCO BusinessWorks. In our previous sessions, we explored the fundamentals of connecting to a database using JDBC connection and learned how to retrieve, update, and insert data. If you missed those lessons, no worries, you can catch up anytime. Today, we're taking a significant leap forward, delving deeper into database interactions by uncovering two powerful activities, SQL Direct and CallProcedure. But that's not all. I'll show you how the local transaction group can save your operations from unexpected disasters. And wait for it, stick with us until the end to unveil the secrets of the CrticalSection group and how to manage concurrency in your flows. Remember the exercise from our last lesson? We had two tables in our database, one for addresses and one for the people associated with those addresses. We're going to pick up right from there. Imagine this scenario. Your flow absolutely must insert a new address and immediately after, the person who resides at that address. Do you see the problem? We need two successive insertions, the first for the address and the second for the person. For the person, we'll need their name, surname, date of birth, etc., but also the ID of the address. How do we get that? Easy. We need to retrieve it from the first address insertion. But what happens if the second insertion fails? We certainly don't want that address to remain orphaned in the database. This is where the local transaction group comes into play. This magical group ensures that its internal flow executes atomically. It's all or nothing. In other words, if the address insertion succeeds, but the person insertion fails, the address insertion will automatically be rolled back, since the database allows us to do so. Think of it like a simple commit that doesn't get executed. It's truly a lifesaver for your data. To manage all of this, we'll create a new integration process called insert address and person. Now, for executing slightly more complex queries, let's briefly forget about the update activity and welcome SQL Direct. This activity lets you input the SQL statement directly. It returns a collection of rows and columns. For each column within a row, the output provides both the column's name and its value. It's important to note that the value itself is of any type, meaning TIBCO BusinessWorks can handle various data types returned from your database without requiring a predefined type for each column. But first, we'll create the input XSD for our process. This XSD will contain all the fields for both the address and the person, which we'll reference at the start of our newly created process. Next, we'll reference the start with this element and get ready to write the SQL statement for insert the address. I know it can be a bit tedious with all the quotes and commas, putting them in right place, but the advantage is huge. We can use the returning ID clause to get the ID automatically generated by the database. This is pure gold because it allows us to populate the ID address for the person's insertion in the JDBC update activity. When a process has already referenced a specific resource, like a JDBC connection, that resource is automatically associated with the activities that utilize it. Let's write the SQL statement for inserting a person, configuring the parameters just like we covered in the last lesson. For the activities input, we'll use the person's data coming from the start activity. However, for the address ID, we need to retrieve it from the SQL Direct activity, specifically from the value of its column. You might run into an error here, and any type can't directly be cast to an integer, but I'll show you a neat trick. And any type can be coerced, meaning you can explicitly tell it what type you expect. This works whether the type is complex coming from a custom XSD schema you created, simple type, or a native type, like the integer we're expecting in this case. So we map it from value SQL diarcher, now type integer, that we take from the first occurrence where the column name is ID. Now, let's include our queries inside the local transaction group and select JDBC as the transport. This means if the address insertion fails, that's fine. But if it succeeds and then the person's insertion fails, the inserted address will be automatically rolled back. By the way, preparing these videos takes a lot of time and dedication. You'd be doing me a favor. You could like this video and subscribe to the channel if you enjoyed it. And if you have any questions at all, please don't hesitate to write them in the comments. In the process operation, we'll insert the call to the process we just created. I've already prepared an XSLT to use in the input operation call for a Joseph, born in 1995, who lives in London. Let's test it out. Everything works perfectly. Both the address and the person have been inserted correctly. The address now has ID 11, and the person is linked to that address. We can confirm this in the database. Both Joseph and his address are there. Joseph was correctly inserted into the person table, and his London address was also correctly inserted into the address table. But what happens if we try to introduce an error into the second query? Let's imagine we deliberately attempt a wrong cast, trying to convert a string to an integer for the address ID. We'll change the input for a new person, Laura, who lives in New York and born in 1998. Let's change the last name and, most importantly, the tax code, as it's a unique field in our database. Now, let's run a test to see what truly happens if the first insert will indeed be rolled back. As we expected, the update failed. However, the SQL direct activity successfully inserted a record, returning an ID of 12. But when we check the database, that record simply doesn't exist. It was completely rolled back, exactly as we wanted. Writing complex queries directly in SQL Direct can be, as we've discussed, a bit cumbersome. The good news is there's a super efficient alternative, the CallProcedure activity. With the CallProcedure activity, we can connect directly to a function that's already set up in our database. I've already created this function. It takes the address fields as input, inserts the address, and then returns the newly generated ID. The CallProcedure activity in TIBCO BusinessWorks will directly link up with this database function. The activity's input and output parameters will be automatically generated, precisely matching those defined in your database function. Specifically, the input will take the fields needed to insert the address, and the activity's output will provide you with the generated ID. So we insert the ID from the procedure's output as the address ID input for the person's insertion. We'll test this again with Laura, who lives in New York, the very person we couldn't insert before. I'll see the generated ID in the output and the correct insert into person. On database, we can see the record with Laura and the address in New York. Now, as promised, it's time to unveil the functionality of the CrticalSection group. Let's start with a common problem. Imagine two execution flows. One inserts an address and another immediately after reads all addresses. We can't know for sure which task the scheduler will execute first. What happens if the insertion has a slight delay and the read happens first, even if the reading flow started later? The newly created address won't appear in the read. To solve this concurrency problem, the CrticalSection group comes to our rescue. We associate it with the JDBC resource for both the insertion and the read operations. In essence, it acts as a lock. It prevents the execution flows from simultaneously entering different critical sections. Only when one critical section finishes does it release the lock to the other flow, which can then finally access its own critical section. We had already created the process for address insertion in the last lesson. Even though it handles batch insertions, we can use it to insert a single record. Easily will be inserted just the first occurrence. Now, let's create our getAddress process, which will retrieve all addresses from our database. Fix the statement to get a lot addresses. The process input is not necessary, and for process output, use the element we already created, where we map the output from the query. Don't forget to get out the parameters and inputs from the query, because I copy and passed from another process. As usual, we'll create two operations that will call our integration processes. For the insertion, for example, we'll use a Miami address. Next, we'll create two main timers to trigger these two operations. To simulate them starting in succession, we'll make the address retrieval flow sleep for a certain period. And to simulate a snag in the insertion, we'll make the insertion flow sleep for a longer duration. To make a flow sleep, we use the sleep activity, which takes milliseconds as input. For the retrieval process, we'll place the sleep activity in its main flow for 2000 milliseconds or 2 seconds. This simulates that the retrieval flow starts after the insertion flow. To simulate the insertion snag, however, we'll put the sleep activity in the integration process before writing to the database for 4 seconds. Let's launch the debug. We can see that getAddress waited 2 seconds before starting, but it's still executed before the insertion, which waited for seconds. The insertion correctly added the record, but if we check the output of getAddress, the Miami address is missing. However, if we look directly at the database, it is present. This discrepancy is precisely due to the delay in the insertion. Now, let's incorporate critical sections for both the insertion, including the sleep that simulates the snag, and for the read operation too. To link these two critical sections, we need to enable the shared lock flag in the General tab and select the same module shared variable for both activities. You can choose any available one. For instance, we'll use application name, which was created for our logging process. Now, let's try inserting a Boston address and run a test. When we look at the output from getAddress, voila! Boston is present in the retrieved list. It works. This is because the insert operation entered the critical section first, so getAddress waited for the insert's critical section to complete before executing. Alright, TIBCO BusinessWorks heroes, here's your final challenge. Create a flow that manages people and addresses. Check if the address already exists. If it does, use the existing ID. Otherwise, create it first. And for a perfect solution, always use LocalTransaction and CrticalSection. Let me know in the comments if you have any questions. If you like the video, hit like and subscribe. See you next time.